Okay, so today we're going to work on multiplying functions, and if you are working with the software program IXL, this would be letter O, section 2, multiplying functions. Notice that my circle is closed, so that means f times f of x times, still a closed circle, g of x. I'll do an example in a few minutes where this circle is open and that becomes a composition of functions, which is different. Our f of x in this example is equal to negative 4x plus 6, and my g of x is equal to negative 3x plus 4. Notice that I have two terms called a binomial times another binomial, and there are different ways that I can multiply this, but I'm going to use the FOILing process, which is first terms, this guy times this guy, and that would be a 12x squared. Outside terms, this guy times this guy, negative 16x. Inside terms, these two, and my last terms, the 6 and the 4, and I have a positive 24x. And then it's time to combine like terms, and I have in the middle, beside each other, two like terms, negative 16 minus 18, negative 34x, plus 24, and that's my final answer. Let's move on to another one. And this again has a closed circle, so this is going to be f of x times g of x. And in this example, our f of x is equal to 2x plus 6, and my g of x is equal to x squared. Now I would really prefer, because I'm going to have to distribute, that my x squared be on this side. So I'm going to use my commutative property of multiplication to change the order. And now I'm going to use my distributive property. So x squared times 2x. If you're having trouble with your exponents, when your bases are alike, think about how many total x's you have. We have 2 x's and we have one more x. That makes a total of 3 x's. The shortcut, I have like bases, so I'm adding the exponents. There's no exponent written, so there's a 1. 2 plus 1 is where I'm getting my 3. And then x squared times 6. And then that guy's finished. Okay, we're going to move on to another example, the composition of linear functions. And again, if you're using the IXL software program, this would be the letter O and then section 4. My circle is open. That signals this is the composition of functions and it's not multiplication. This is going to be written into a workable format, which is g of h of x. And we're going to start on the inside and replace h of x with what it equals. In this example, h of x is 6x. Now, this is saying go to your g of x function, and this is what will take the place of x. So I need my g of x function, which in this example is x plus 5. Now, this x is going to go away, and the 6x is going to take its place. And that's my final answer. Let's look at one more example, same concept. So this guy is going to be f of g of x, and g of x is x plus 3. So I have f of x plus 3. It says go to f, which is equal to 6x, and this x is going to go away, and the x plus 3 is going to take its place. Now I have a little algebra 1 to do, which is just some distributing, and I'm going to get 6x plus 18 for my final answer. Okay, now we're going to go to still composition of functions, but now sometimes we're going to have some linear and quadratics, and notice we have a value this time. Similar process, I'm going to do h of g of negative 3. Well, g of negative 3 says go to g, plug negative 3 in. So I go to g, and I plug negative 3 in every place that I have an x. That's going to be 3 times 9, order of operations, plus 12 plus 2. 27 plus 12 plus 2 is going to end up giving me 41. So g of negative 3 equals 41. Go to h, which is equal to x squared, and this is what takes the place of x. So that's going to be 41 squared, which is equal to 1,681. All right, similar example. F of g of -2. Go to g, put in -2. Here's g. Notice my use of parentheses with the negative and the square on the outside because that's going to become a positive value. So this is going to become 4 minus 12, -8. So this is going to be replaced with -8. And now I'm saying go to f, put in -8. Well, f of x is equal to 3x, and the x is going to get replaced with my -8, and I got a -24 for my final answer.